Hello everybody. Welcome to Creating the Basic Adaptable Game Engine Library, Part 19, Drawing Sprites in a Game. In the previous videos, we've been putting together the Game class. The Game class handles creating a window for us and also handles some of the game logic. For example, it will run a loop called the game loop that runs 60 times per second, and it draws all the sprites to the screen. Now the way it does that is there's a main group called group, and it calls the draw method on that group. The way the draw method works for a group is it calls the draw method on all of its contents. However, up to this point, we haven't actually written the draw code for the Sprite class. So we're going to go ahead and do that now. So let's go ahead and switch over to our development environment. And let's take a look at the Sprite class. In the Sprite class previously, we mostly set it up to store a lot of data corresponding to classes we previously created that we know we're going to need when we're drawing and using sprites in a game. So the Sprite class, it extends the entity class. It's going to store a position. It's going to store a texture that has the image related data. We'll use a rectangular shape to represent its boundary. We'll also store the width and the height in some variables, and a Boolean will determine if we can see something on the screen or not. And the last time we wrote this class, we created a draw method. We need to because it extends the entity class, which has a draw method, but we haven't written the code yet. Now is the time to write this code. But not only this code, at this point, since we're about to use the Sprite class, let's also write a constructor and some other helpful methods to set the values for each of these fields within our class. So maybe let's start off with a constructor. Right? And there's lots of information related to a sprite, but I'll just initialize the objects and create set methods for setting other pieces of data. So first comes the constructor, public sprite. Within the constructor, what do we need to set? We need position, right? That'll be a new vector object. We have texture, that'll be a new texture object. We have the boundary, that'll be a new rectangle object. And then we'll have visible, right? By default, let's say everything is in fact visible. All right. So let's create some set methods so we can put values in these. For instance, let's say public void set position. I'll take in double X, double Y. We'll just say position.setValues X and Y. Right, maybe we'll next do something for setting the texture. Right, you might notice that I didn't set width and height. I really don't know the width and the height unless, well, I don't really even have default values for width and height. But we'll default the values when a texture is loaded. So public void set texture. And this will take in a texture we'll call text. Here, we'll say texture equals text. But also, the texture, when that's loaded, the texture class contains a rectangle called region, and that tells you how large the image is, or what part of the image to draw. In some cases, in later videos, we'll talk about things like sprite sheets and tile maps. For now, the region, the rectangle associated to a texture, is the size of the associated image. So we can take that data from the texture, right, from the texture.region.width, and we'll set that as the default width for this object, for this sprite. And same thing for the height. We'll take the region height, and we'll use that as the default size. Now, it might so happen that when you set a texture, the image is at a much higher resolution or it's too large for your game. So in case you want to change the size of an object, let's change the size of a sprite, let's also include a set size. We'll take an int width and an int height. And we'll say, just to make sure there's no confusion, this dot width equals width, and this dot height equals height. All right, I think that's everything we're going to need for now. Later on, we're not doing collision detection right away, so I'm not going to worry about changing the boundary yet. What I do want to spend a lot of time focusing on is this draw method. Now, previously, we learned how to draw images on a canvas using a graphics context object. And the syntax was something like context.drawImage. Then we need an image, right? So we could say texture.image. Then we could say position.x and position.y. And in theory, that's all we need. We're going to work a little bit harder, though, to do this. Right? The drawImage function has lots of different sets of parameters you can use. And looking ahead to the future and kind of laying some groundwork now, we are going to have situations where we only want to draw part of this image. Right? So we want to use the other data stored in texture, right? The information about the rectangular region of the image that we want to draw. So we're going to use a different version of this function. We're going to use a 9-parameter version. Right? We want to, in particular, define the source rectangle region of the image and the destination rectangular region of the canvas that we want to draw this on. So what we're going to do is we're going to say we're going to start at 0, 0 for now, and we want to draw something which is, oh, not 0, 0, sorry. The first part is the source rectangle region. So that's going to be texture.region.left, because that's the x. Texture.region.top, that's the y. Then texture.region.width and texture.region.height. Right? This is starting to tell us where we want to draw. Then we have to say, what's the rectangular region on the canvas we're going to draw this to? And for this particular version, we also specify it as a rectangle. What I'm going to do, and I'll explain why in just a moment, this dot width, this dot height. Okay, in this case, I'm saying draw this starting at 0, 0, the top left corner of your canvas, and then draw it in a region equal to the width and the height specified by this class. And the width and height stored in the sprite might be different than the width and the height stored in the image, so this would also resize images for us. However, you might be a little bit concerned that we're not using the x and y coordinate that's stored in position. Right? We could change this to position.x, position.y, and then these parameters would change to x plus width and y plus height. There's actually a much nicer, cleaner way to handle this that will also become important later on. Before we draw the image, we're going to use another method from graphics context called setTransform. What setTransform does is it applies a transformation to whatever is drawn after the setTransform method is set. And so this has a little bit to do with matrix algebra, which we'll talk about slightly in a future video. But the idea is the transform can involve both rotation and translation components. So in this case, there's no rotation yet. We're not talking about rotating images, but these first two lines, lights went off. These first two lines have to do with the rotation of the object, and these numbers specify that there's no rotation yet. And these values here are, of course, the translation, right? And whatever gets drawn, we're going to want to translate it to the left by position.x and to the right by position.y. So this translation is applied to this destination rectangle. So it moves the object into the position we'd like to see. Right, the last thing I'd like to do, I haven't used the visibility yet. Right, visibility we set to be true, but there might be some cases in which you set visibility to false. For example, you might have an end of game message that you want to display, but you don't want it to appear right away. You load it right away, and then you have it become visible later on in the game. If something is not visible, we do not want to draw it to the screen, and for that reason I'm going to add one more line of code to the draw function right up at the beginning. If it's not the case that this is visible, then return. I'm not returning a value because this function has return type void. In this case, calling return just exits out of the method before anything else happens. So if a sprite is not visible, do not continue, just return and exit this method. All right, with this bit of code, we can now draw sprites. It's very exciting. To test this out, let's go over to the test game class. And we're going to go ahead and set up a sprite. All right, so let's create a sprite. I'm going to call this ball. You might recall from the video where we learned about how to draw images on canvases. I have an images directory which contains an image of a basketball. It's rather large, but we can change the size later. All right, so we have a sprite called ball. In the initialize function, we need to set that up. So ball is a new sprite. Ball, let's set the starting position to be something like 1010. And I need to load in a texture. So set the texture to be. And the way textures are loaded, it's a static method in the texture class where I give it the path to the image. So this is in the directory images. It's basketball.png. PNG. Right? If I was going to create multiple balls, I would take this texture and store it in a different variable so I could reuse it in all the sprites. Since I'm only using it once, I'm not going to store it in a variable. I'll just load it in here like so. All right, once this is created, remember the game class only draws things which have been added to the main group. So I also want to say group.add ball. All right, now if that's done, we should be able to run this code and we should see a window with a basketball in it. Let's see how this works. Hey, there we go. Okay. It's not too exciting. It's just kind of sitting there. It's also extremely large, but that's the default size of the image. Let's go back to the code for a moment. Let's shrink it and let's move it across the screen. So in addition to setting the texture, let's also do ball.setSize. Let's make that maybe 50 by 50 pixels. And then in the update method, let's say ball.position.addValues. Let's add 2, 1. So it'll go across the screen kind of at a diagonal, slightly more quickly to the right than down. All right, we've added a bit more code. Let's go ahead and run our test. We should see a moving basketball. Hey, there we go. There it is. It's very little. And it's going. And it's going. And it's gone. All right. Things are going quickly now. In this case, not only just is the basketball moving quickly across the screen, we're starting to be able to do some really great things with this library. We can now create sprites, which is great. However, it's not really a game unless it's interactive, right? I have no control over that sprite. These values are added. So starting in the next few videos, we're going to create something called the input class, which is going to allow us to use keyboard input to control different sprites that are part of our game. But for this video, we've accomplished our goal. We can now draw sprites in a game. Thanks for watching.